Hello and welcome to this video for basic sentential logic, informal fallacies, and cognitive biases. This video corresponds most directly to material that's in section 3.5 of the text, and the specific topic is what you can and can't do. So there are some common misconceptions about the sorts of things that you can do when doing a proof and what you can't do when doing a proof. And I'm also going to just at the end, after going through that, run through a few more examples that use all of the inference rules and conditional proof. But first off, let's get into the topic of what you can't do when applying inference rules. So these are some things that often people think you can do, but you really can't. And some of them are more obvious than others. So the first one is that whole lines in the rule, the schematic of the rule, have to correspond to whole lines in the proof. So here's an example of modus tollens. Here's the schematic of the rule for modus tollens. If you have a conditional and you have the negation of the consequent, you can derive the negation of the antecedent. And here's an application of that rule in a real proof. Premise 1 is a conditional, premise 2 is the negation of the consequent, and on 3, A is derived, which is the negation of this antecedent. Antecedent is not A. We can negate that by taking 1 tilde off. Now, what do I mean by whole lines in the rule have to correspond to whole lines in the proof? Notice that every one of these lines here corresponds to one of the lines in the schematic. So this is a conditional, that's a conditional. This is the negated consequent, this is the negated consequent. This is the negated antecedent, this is the negated antecedent. What if, though, it looked like this? Someone might think, okay, here is a conditional. What's the consequent? Q. I'm going to need not Q. Oh, look, here's not Q. So I can do modus tollens. Well, you can't really do that. And the reason is that here, the thing that corresponds to the negated consequent isn't the whole line. The negated consequent would be not Q, but not Q isn't this entire line. Okay, so you can't do this. Here, the thing that would correspond to the negation of this isn't the whole line. It would just be this part of the line. Okay, so don't do that. Now, the problem isn't that. I just want to be clear about something. The problem with this isn't that this is a compound statement. In fact, not Q by itself is a compound statement, right? Because, for example, suppose it was this, okay? We have a conditional, if not A, then Q or K. Here's the negation of this consequent. The consequent is Q or K. This is the negation of Q or K. This is fine, because still, in this case, beta, the consequent, is this disjunction Q or K. Not beta is the negation of that whole disjunction. So the problem in this example isn't that this has two atomic statement letters as part of a larger compound or anything like that. The problem is that this whole statement isn't the negation of that consequent. But in this case, it would be. This is the negation of that, so this would be fine. Okay, so whole lines in the rule have, the rule being this, the schematic of the rule, have to correspond to whole lines in a proof. We'll see when we get to chapter 4 that there will be a different kind of rule that we have, replacement rules, that can be applied to parts of lines. But the inference rules from chapter 3 can only be applied to entire lines. Okay, so the next thing you can't do. The operators in the specified rule have to be the same ones in the proof. Okay, so for example, here's modus tollens again. This is fine. Conditional, negation of the consequent, derive the negation of the antecedent. Here's the schematic of the rule. Sometimes students will come up to my office hours and they'll ask questions like, can you use modus tollens on a disjunction? And what they mean is something like this. Suppose instead of a conditional, this was a disjunction. Can we still do modus tollens? Where here we'd have a statement with two components, one on the left, one on the right. We have the negation of the one on the left, derive the negation of the one on the right. And the answer is no. Modus tollens calls for a conditional here, so this has to be a conditional. By the way, when I say except for negation, what I mean by that is something that I've mentioned in the chapter, that you can negate a statement either by adding or subtracting one tilde. So here in the schematic of the rule, we negated this antecedent by adding a tilde. Here I negated it by subtracting a tilde. That's all this means. Okay. So don't do that. Next up, and this is actually a very common source of problems. When you negate something, so for instance, sometimes you have to negate the antecedent. If you're using modus tollens, you take the antecedent of a conditional and you negate it and write that on a new line. When you negate something, make sure you're negating the correct thing. So here is an attempt, and this is actually wrong, but we'll explain why it's wrong, to do modus tollens. Here we have a conditional. If A or B, then Q. Premise 2 is the negation of the consequent. So far, so good. We have the pieces we need for modus tollens. But here, what's derived, or the person doing this proof, let's say, was thinking this way. Oh, the antecedent is A or B. I need to negate that. So I'm going to put A or B here and then just kind of put a tilde in front of it to negate it. That's what this person is thinking. The problem is that what you need to do here is to negate the antecedent. Here it's alpha. It's not alpha. Well, what's the antecedent? The antecedent is A or B. This is not the negation of the disjunction A or B, because this tilde isn't negating the disjunction. This tilde is just negating the first disjunct. So this isn't the way it should look. It should look like this. Here, the whole disjunction is being negated by this tilde. Okay, so this would be right. So here it's the antecedent that's negated, not just the first letter in the antecedent that's being negated. Related to this, the next thing you shouldn't do is don't distribute negation operators. What does that mean? Here's modus tollens again. This is a correct application of modus tollens. We have the conditional, negated consequent. Here's the negated antecedent. This is correct because the antecedent is A or B, and here the negation is the entire disjunction A or B. So far, so good. Problem is sometimes students think, oh, the negation of A or B is the same as not A or not B. And so instead of writing it like this, not A or B, they might write it as not A or not B because they think they're equivalent. But they're not equivalent. Okay, not A or B is not equivalent to not A or B. Ditto, so don't do that. Ditto for conjunction. Not A and not B isn't the same as not A and B. And if you think it through a little bit, you can sort of see why they're not equivalent. So this is saying that the conjunction is false. For instance, if I say it's false that I have apples and bananas. Okay, someone says, hey, do you carry apples and bananas, right? Maybe they want to know if I have both of them, and I say, well, no, I don't have both of them. It could be that I have apples, I just don't have the conjunction. I don't have them both, right? So that conjunction could be false even if I do in fact have one of the conjuncts. This is saying that actually both of them individually are false. I don't have apples, and moreover, I don't have bananas. It's not just that I don't have the conjunction. I don't even have either conjunct by itself. And you can also talk yourself through the disjunction version of this to convince yourself that they're not equivalent. I think the reason some people are inclined to distribute these tildes is because for some arithmetic operators you can do this. So for example, negative 5 plus 3 is minus 8, which is going to be the same as minus 5 plus minus 3. That'll also give you minus 8. Now, it doesn't work for all arithmetic operators, but I think that this is maybe one reason why some people find it intuitive to do it with conjunction and disjunction, even though you can't. So anyway, don't distribute negation operators. Next up, don't mentally commute disjunctions or conjunctions, or conditionals for that matter. So here is modus ponens. We've got a conditional, antecedent A or B, then Q. Here on line 2 we have B or A. Now of course you can just look at this and you can tell that A or B is equivalent to B or A. Those mean the same thing. And so you might feel invited because of that to assume you can do modus ponens here, that this just is the same as that antecedent, so you can do modus ponens to get the consequent. You can't do that. Now, of course, if we had a rule that let you do that, it would be a truth-preserving rule and the system would work, but we don't have that rule. But don't worry, in Chapter 4, we will get a rule called commutation that will let us swap the order of conjuncts in a conjunction or disjuncts in a disjunction. So even though we can't do this in Chapter 3, once we get to Chapter 4, we'll have a rule that will just let us do that. Okay, next up, what can you do when applying inference rules? So these are things that sometimes people don't realize that you can do, but in fact you can. The order of lines in the rule doesn't have to correspond to the order of lines in the proof. And so here is the schematic of the rule, and you can see that the conditional is up above the negated consequent. And in the proof where we're applying the rule, that's also the case here. The conditional is up above the negated consequent, but it doesn't have to be. Okay, all this is saying, the schematic rule, is that somewhere you have to have a conditional and somewhere you have to have the negated consequent. But what order they're in, they don't even have to be next to each other. One of these could be on line 2 and the other one could be on line 12. You just have to have these two pieces somewhere. Okay, so they don't have to be in the same order. They don't have to be next to each other. Now, of course, the one down here is the one that you're deriving, so it's going to always be at the bottom at any point that you're using a rule. But these can be anywhere. Yeah, you can cite the lines in any order. So here's modus tollens, and the justification here is lines 1 and 2 modus tollens. But it would be just as fine to write lines 2, 1 modus tollens. The only thing you need is just make sure that you have the line numbers where all of the required parts are. So modus tollens requires a conditional and a negated consequent. You just have to put the line numbers where those two pieces are located, but there's no specific order that you have to put those in. For simplification, you can simplify either conjunct. Okay, so if I have P and Q, I can simplify P, I can simplify Q. Okay. For disjunctive syllogism, you can have the negation of either disjunct. So remember disjunctive syllogism, I have a disjunction, I have the negation of one of the disjuncts. Here I have the negation of the first one, so I derive the second one here. So I can have the negation of the first and derive the second. That's fine. But I could also, as in this example, have the negation of the second one and derive the first. That's fine as well. When creating a disjunction with DI, you can decide the order of the disjuncts. Okay. Or another way of putting that is you can decide whether your new disjunct is on the left or the right. So here I've got Q. I'm going to use DI. I can either put the new disjunct on the left or on the right, as I did here, or I can put it on the left here. So you can sort of decide the order if you're creating that disjunction from scratch. And ditto for conjunction. I've got two statements here. I'm going to put them together into a conjunction. I can go X and Q. I could go Q and X. Either of those is totally fine. Okay, so that's just a quick run through of some things that people sometimes get mixed up on. Next, I just want to go through two more practice proofs that use all of the rules, including conditional proof, and also another example of how to think of some proofs by sort of thinking strategically, especially when conditionals and the use of conditional proof are involved. So here's a proof. We have four premises, and the conclusion is if B, then D. And I'm going to try to do this with conditional proof. And what I mean by that is I'm hoping, if it works, that my proof is going to look like this. My last line is going to be the conclusion. That's how you always are going to try and derive the conclusion on your last line. And so just suppose that's line Y. I don't know how long my proof is going to be, but my hope is going to be that whatever Y is, the last line, it's going to be if B, then D. Okay? And my thought is I'm going to use conditional proof to get this. Specifically, I'm going to assume the antecedent I want, B, and then derive the consequent, D. So it's going to look like this. I'm going to start a subproof, assume B, eventually derive D. I don't know how this is going to work, okay? But I do know that my goal is going to be to get D, so I can put that here. That's going to be the last line of my subproof. And I don't know how many lines it's going to take, so I'll just put X. And then once I've done that, I'll close the conditional proof, and I'll get if B, then D. If the ACP is always my antecedent, and the last line is always the consequent, if B, then D. So this is what it'll look like. This is my plan for the proof. Now all I have to do is figure out this middle part here. How am I going to get D after I've assumed B? So I'm going to go ahead and start line 5, assume B, assumption for conditional proof. And my whole goal now is just to somehow get D. Okay. Now, there's a number of ways I could try to approach this, but here's one. Now, you may or may not notice this yourself if you were doing this proof, in which case you wouldn't be able to do the strategy I'm going to talk through right now. But if you do notice this, this is something you can always do. I'm noticing that, look, I've got B here and I've got not B here. I've got two statements that are inconsistent, where one is just the negation of the other one. Whenever you have a situation like that, you're always two steps away from being able to derive anything you want. And right now what I want to derive is D. So I can derive D in 2 steps. How? First off, I take the thing I'm trying to derive, whatever it is, in this case it's D, and I'm just going to use DI to get B or D. So I'm just going to take one of my 2 contradictory statements, use DI, I'm going to use this one, I'm going to keep B, and then just go B or D. The thing I'm going to try to prove is now just disjoined onto here. Once I've done that, because I have the negation of this same thing, I can use disjunctive syllogism. I have a disjunction, I have the negation of the first disjunct, so I can derive the second disjunct by DS. Well, that was my goal. My goal was to assume B to try to derive D. I've done that. I'm going to close my subproof if B then D, 5 through 7 conditional proof. Now suppose you didn't notice that. Suppose you didn't see that you had a statement and the negation of the same statement up there somewhere, and you didn't know that you could do this little trick whenever you have that. What would you do? Well, you have, I'm not sure, actually. Try to do it without this. I don't know if I've actually tried to do it without using this particular trick. Probably can, but give it a shot. I'm going to go ahead and move on to another example, though. Maybe I'll work this out in a future video or in class or something without doing it this way. But let's do another example. Here's a proof. Notice, though, that in this case, the conclusion is not a conditional. It's a conjunction. So my last line, and I don't know how many steps it's going to take, so I'll just call the last line line X, is going to be this. I also don't know what the justification is going to be. But here's one way I could get this. It's a conjunction, so one way I could get this is if I could somehow get the first conjunct. I'll just call this line X also. Of course, these aren't really the same line number, but this is just a placeholder for whatever those lines are. If I can derive the first conjunct, if R then A, and then on another line derive the second one, I can just use the rule of conjunction on these two lines to get this conjunction. So at this point, I'm thinking, well, how can I get this? And then how can I get this? These are conditionals. So I can use conditional proof to get them. Now, I could also perhaps use other things besides conditional proof. You don't always have to use conditional proof every time you're trying to derive a conditional. Sometimes there's other ways to do it. But in this case, that's going to be my strategy. Well, what's that going to look like? How can I use conditional proof to derive this one and this one? Well, the first one, the conditional I want is if R then A, so I'm going to assume R, try to derive A. This will be my ACP. I'm going to go for a while. I don't know how many steps there will be here, but eventually I'll derive A, close that off, and then that'll be how I get if R then A. Same thing here. I want this conditional. I'm going to assume the antecedent and try to derive the consequent. So I'm going to assume S and then try to derive the consequent here. So if I'm successful, this is what my proof will look like. I'll have one conditional subproof to get this one. I'll have another conditional proof subproof to get this one. And then once I've got both of these, I'll conjoin them like that. So let's get going. First off, try to get the first conditional, if R then A, so I'm going to assume R. Now my goal is just to get A. How can I get it? Well, I've got R. I can get D and A by modus ponens and then just simplify A. So I can get D and A by modus ponens on 1 and 4. This is that antecedent, so I can get the consequent by modus ponens. And then I can just simplify that second conjunct off, A. Well, that was my goal, was to derive A. Assume R, derive A. So I can close my subproof now. And I've got if R, then A. Now it's time to try to get this second conditional, if S, then B. I'm going to assume S, see if I can derive B. So here's S. Assumption for conditional proof. Is there any way I can get B? Sure enough, because I have a disjunction here, I have the negation of the first disjunct, so I can get the second disjunct by disjunctive syllogism. Notice one thing I'm not going to do here is cite any of lines 4 through 6. At this point, once I've closed this first subproof off at line 6, remember the rules for conditional proof. Lines 4, 5, and 6 are off limits. Those are quarantined now. But I'm okay. I'm not citing any of those lines. I've cited 3 and 8. I'm going to close this subproof. I'll get if S then B. And now I'm going to conjoin lines 7 and 10 to get this. Another thing I want to point out, and I could have pointed this out in the previous proof as well because the same thing is true there. Notice that I never used line 2. So go back through this entire proof. At no point did I derive a line whose justification appealed to premise 2. And if you go back to the proof I did earlier, where it was just one big conditional proof, there was also more than one premise, actually, that I didn't cite. That's okay. It's not part of the proof process that you have to cite every premise that you're given. The requirement is that you have to derive the conclusion from the premises using the rules, but you don't necessarily have to use them all. Sometimes you might not have to use any. It's generally the case that most of the proofs you see, you will end up having to cite all of the premises. But don't think that that's a requirement. If you can get the conclusion and it turns out there was a premise you didn't cite, that's probably fine. As long as your proof is correct, every line you did derive, you derived correctly. That's the key thing. Okay? And that's it for this video. Do a lot of practice and good luck on the quiz or final.